Now that we can name simple ions of metals and nonmetals using a periodic table, we can put those ions together to build ionic compounds. And it turns out to be quite simple to name those compounds. All you've got to do is name the kinds of ions that are in the compound. For example, sodium chloride. How do we figure out that name? We have to look at the formula and figure out what kinds of ions are present. Now if you look at the periodic table, sodium is in column 1. Everything in that column has got a +1 charge. Chlorine is in the halogen column. Everything in that column forms ions with a -1 charge. Now all we have to do to name the compound is name the two ions. This is a sodium ion. I'll take the word ion off. And this is a chloride ion. Remember, when we're naming negative ions, we chop the end of the element name off and replace it with IDE. So the compound that I've got is sodium chloride. It's that simple. If you know how to name the ions, and if you know how to take the formula and break it up into ions so that you can recognize which ions are present, you can name ionic compounds now. Let's do another one. Suppose I give you the name and ask you for the formula. Potassium fluoride. All right, well, here's how my process goes. I am going to have my periodic table handy. Potassium. I'm going to look at where that is on the periodic table. There it is. It's in the +1 column. So I'm going to do this process backwards. I'm going to write potassium ion there. And now I need the formula for a fluoride ion. Okay, so I look for something that looks like that. Fluorine is the element that it comes from. And it's in the halogen column, and it's got a -1 charge. So I can write down the formula for that. Now I can put them both together. Plus and a minus will neutralize each other, and there's the formula for potassium fluoride. Now you need to be able to go both ways. If you're given the formula, you should be able to work out what the name is. And if you're given the name, you should be able to work out the formula as well. Now, what makes this a little bit tricky, not too tricky, but a little bit tricky, is when you've got ions that don't just have the same charge. For example, let's do aluminum oxide. Let's write the formula for aluminum oxide. All right, I'm going to look at my periodic table, and I find aluminum here. It's got a +3 charge. And I find oxygen on my periodic table. There it is. It's in the -2 column, so I have O -2. Now, if I put those together and write, that doesn't work, because this would be a +3 and this would be a -2, so I would have an overall +1 charge if I just had ALO. Now, what I can do to make this work out is try adding additional oxygens on. There's too many positive charges, so if I try to add another oxide on, then it's -4 and +3. That still doesn't balance. So how about I add another aluminum? Now I am tipped too far over onto the positive side. I have a +6 total and a -4. If I add another oxygen, everything is perfect, because now I have +6 and -6, so everything balances out. There are 2 aluminums and 3 oxygens, so the formula is going to be... Now, notice something. We worked this out logically, but there's a shortcut that you can take sometimes. When you have 2 ions with different charges, you can do this trick. Take that 3, and it's going to end up there. take this 2, and it's going to end up there. So in other words, you can swap the charges as subscripts. So you're going to have different charges when you do this. This little trick for very quickly working out what the formula is going to be. For example, if you've got magnesium oxide and you want to work out the formula for that, you'll look at your periodic table. Magnesium is in the second column. There it is. Everything in that column has a +2. And oxygen is in a column where everything has a -2. And when you put these things together, they go together 1 to 1 just fine. The +2 and the -2 are balanced, so you get this. I'm not going to try to swap the subscripts as charges. Like I wouldn't put a 2 here and then a 2 there. I have Mg2O2. That's not the simplest formula that I can have. The simplest ratio, that would give you a 2 to 2 ratio between magnesium and oxygen. A 1 to 1 ratio is a lot simpler to look at. Simpler is better. All right. So you can do the hardest ones with this little trick. Let's do a few more. Now we've been going from the name to the formula. Let's go from the formula to the name. Let's suppose I have this compound. Now I'm going to try, and if I want to name it, I have to name the ions inside. This one's pretty easy. It's an oxide ion. This one, though, I know what the charge has got to be. Because if this is a -2, this has to be a +2. You can work that out. The charges on the ions in here have got to be balanced because it's electrically neutral. Now, I can't just say iron oxide. Why not? Remember from the last video, I colored in this area on the periodic table where you have metals that can have variable charges. So they can have more than one charges. And when you have got an element that is inside this area here, you need to use a stock number, a Roman numeral, that tells you what the charge is. Iron is in this area. So I can't just say iron oxide. I have to say iron 2 oxide. Now there's another iron oxide that looks like this. What have you got here? You've got an oxide. You've got 3 oxide ions in there. And you also have 2. Can you figure out what the charge on the iron is going to be there? We've done this one or one very similar to it before in the videos. If you've got 3 of these oxygens and each one's a -2, you have a total -6. That means that you need to have a total +6 for both of these irons together. And if you give a +3 to each one, that works out. Another way you can think of this is remember how we swapped the charges as subscripts? You can figure out the charges by swapping the subscripts as charges. So you can put the 3 with the iron. It's the metal, so it'll be a +3. You can put the 2 with the oxygen, and it's a nonmetal, so it'll be a -2. So remember, nonmetals have negative ions, and metals have positive ions. So here are the 2 ions, and I'm going to call this iron, not just iron, but iron 3. I've got to put that Roman numeral there because it's in the transition metal area. All right. So let's do one more. Suppose I have, let's see, Drawing a blank here. Suppose I've got and I want to name that. If I look at the column that these things are in, I can see the ions that are in there. This is a barium ion. And now no stock number, because look where it is. It's in this area of the periodic table. As long as we're outside this area right here that I showed you in the last video, as long as you're outside of this, you do not have to put a stock number on. So I can just say barium. I don't have to say barium 2. And that's a sulfide ion. All right, we'd be all done with naming ionic compounds if these were the only ions that we had to deal with. But all of the ions we've looked at so far have a single element in them. Look at all the ions on this page. There's just one element in there. Now, if we have more than one element inside the ion, we have what's called a polyatomic ion. And that's going to be the subject of the next video.